Good day, Fernando Manalo from ECE42, and today's experiment is the packet tracer build a connected factory solution. And the objectives of the experiment is to explore the connected factory and build a connected factory solution of personal importance to you. The background is, in this activity, you will explore the connected factory. You will then build your own model of a connected factory that incorporates an area of personal interest to you. For the part 1, explore the connected factory. Step 1 is to review the glazing company overview page, and we will do that by going to any PC in the warehouse, and here we will go to the warehouse, and then let's click any PC. So let's click PC PTWPC1 and go to web browser, and then we will go to the web server. And now we can see the company description information. This is the glaze company. Glazing company makes ceramic coatings for space capsules, autoclaves, and ships. The processes in the factory are monitored via cameras, sensors, and people on the assembly lines. The factory also has a store for public to observe the process and buy samples of ceramics that have been in outer space and other exotic areas. And some other information about the company. It also includes the email server www.glaze.com and brief information about the process. Now that we have seen the information, we will go to step 2, which is to run the classic car. The owner keeps a classic car, the old car in the packet tracer in the warehouse that needs to be run. Before that, I think it's best if we notice that none of the fans and windows are on. So if we start the engine by holding the Alt key, and now, yeah, we can see that the north window, south window, north fan, south fan have all turned on. And then we will stop the engine. Step 3, review the connected factory settings. We will go to the factory, find the FIT laptop, and open the text editor. Here is the glazing company factory. And then we'll go to the FIT laptop and open the text editor and the desktop. Then go to File, IP Network. And as you can see, here is some of the information that is listed on the web server. Here are the others. And it also includes all the connected devices, interfaces, and the information about all the devices. And then we will close the text editor. Step 4, use browser to monitor settings. Open the web server on the FIT laptop, and then we will go to the desktop tab. And web browser, we will type factory in the URL box, factory. And as you can see, it allowed us to go to the login area. And first, we will go to login in each area to control the sensors located there. We will first go to the assembly area. Assembly. Assembly. And as you can see, here are the sensors, the actuators, and other things in the assembly part of the factory. Let us go to the assembly part. Here is the assembly part. And as you can see, here's the temperature sensor, assembly fan 2, a start process button, the running light, speed warning, the clay flex sensor, assembly fire sprinkler, RFID reader, which is somewhere here, and the process indicator. And using this web server, we can we can see the outputs of the temperature. We can control the ceiling fan, low or high. Let's turn it to high. And as you can see, the temperature is dropping. For the e-start process, it has no remote API we cannot control it using this web server. For the running light, we can on it, dim it, or off it. For the speed warning, it is the siren speed warning. Now it is activated. The clay effect sensor, which is this one, also have no remote API. The assembly fire sprinkler, we will also turn it on or off. Now let's turn off the siren. The assembly fan 1, which is this one, you can also turn it on. The RFID reader, it shows the status of the RFID reader, wherein we can control who enters or taps the process indicator also has no remote API. Now, we'll go to the preparation area. For the preparation area, we will log in using its preparation. Oh no, it's just prep. Prep and prep. Now we are in the. Let us find the preparation area. Here's the preparation area. In the preparation area, there is the temperature monitor, a fan, here this one, humidity monitor, a humidifier, the casting, the F clay casting. Where is the F clay casting? It is to the thermostat. For the, I think it's like an oven, and the window. Here, this is a window. In using this same interface, you can open the window, turn on the fan. As you can see, the temperature is dropping, and the humidity is at 52 right now. If we turn on the humidifier, the humidity increases. You can also cool the building, the casting, and as you can see, the temperature is dropping. Now we have browsed the preparation area. I will go to the power station. before we do that, we will go back to the map and go to the power station. Then PS, PS. And as you can see there, here are the IoT devices in the power station. The available right now power is 100% and the wind turbine output is at 8 kilowatts. Now we have finished the step 1 and we have reviewed the connected IoT devices. We will go to part 2, which is to build a connected factory solution of personal importance to you and add it to the connected factory. I will go back to the factory, and for my personal preferences, I will add some things on the office, showroom, packaging, and delivery. First, I will add AC to the showroom and the office, along with thermostat. For both rooms. And also an appliance, which is, I think it's quite important for these places, a coffee maker, and also for the office. For the packing and delivery, I will add a fan and also a coffee maker. And to connect all that, I will go to the network devices and use a home gateway for ease. And then, in order to connect that, let us first configure the home gateway. I will name it the personal gateway. Personal gateway, and go to the wireless, and I will turn the SSID to personal gateway. Now, before we connect all these IoT devices, we'll go to advanced and configure it to be wireless, all of them, so that we don't have to, there are less cables. Config wireless. The air conditioner too. Advanced IO config, go to wireless. Advanced IO config wireless. This thermostat 2 will turn it to wireless. To check it, to connect it, I mean, we will first connect it for the air conditioner, AC to D2. So IoT cable to D2, IoT cable to D2 and D0. Now we'll connect. Now let us name it properly. Configure. This is the showroom thermostat. The SSID is personal And as you can see, it connected to the personal gateway. Now we'll go to the IoT remote server, and first let us check the IP address is 192.168.25.1. 192.168.25.1. So we'll add it to 192.168.25.1 admin connect. And now it's connected. To check if it's working properly so that we don't have to reconfigure everything later, we'll use a smart device, or let's say a wireless tablet, and put it on the office. Then connect it to the personal gateway. Personal gateway. Now you see it's connected. We'll go to a browser 192.168.25.1 admin admin, and yes, you can see the thermostat. If we click the cooling, it turns on the air conditioner for that room. To continue connecting my IoT devices, I will first close this and connect the other thermostat. Configure and go to wireless personal gateway, and it should connect. For a moment, yeah, connected. Configure this IoT coffee maker to be wireless, and the other one too. We forgot something. We have to rename this is the office thermostat. Office thermostat. This is the configure showroom coffee, the personal gateway, and then remote server 192.168.25.1 admin connect. See, it's connected. For the other thermostat, we connected to the IoT server 192.168.25.1 admin, and it's connected to for the other For the other coffee maker for the office, we'll first connect to the personal gateway SSID. Personal gateway SSID. And then go to the we'll name this office coffee. IoT server is 192.168.25.1 admin admin it is connected, and to see the progress of our connections, go to web browser and type the IP address 192.168.25.1 admin, and as you can see, we have successfully connected the IoT devices in the showroom and the office. Here's the office thermostat. We can turn it to on and turns on the air conditioner, and also we can stop both the thermostat off to, if we set it to auto, it will go to the preset temperatures. And you can also turn on, can make a coffee or turn on the coffee maker. Now for the fan, the coffee maker in the packing and delivery, I think we also need a window, as during packing and delivery, where you have to, it's in my own personal experience, it gets quite hot and it's always very late, so we will add the IoT window. Go to advanced settings and turn it to wireless too. This one, advanced config, so already wireless. And for this one, advanced IO config, it's already wireless. First, we will set up the packing and delivery coffee maker. So, packing and delivery coffee, and then the SSID is personal gateway. We'll go back to the settings, and the remote server is 192.168.25.1 admin then we'll connect. For the fan, we'll do the same thing. Configure. This is the PD packing and delivery fan. 192.168.25.1 admin and personal gateway. Now it's connected. For the window, we'll do the same thing. Configure tab, display name, PD, window, 192.168.168.25.1, admin. The wireless is personal gateway, and then we'll go back to the settings and let's wait for it to connect. It's connected as you can see, and connect. Now that we have connected it, we can check everything in the tablet. So web browser 192.168.25.1, admin. Oh, I forgot the admin. And as you can see, we have 3 IoT devices in the packing and delivery, 2 in the office and 2 in the showroom, which we all can control. Open, close the window, turn on the fan, turn on the coffee maker, tur- the, turn on the coffee maker in the office. The thermostat is auto. The coffee is on. The other thermostat is, let's turn it off. And that's the end of today's experiment. The packet tracer built a connected factory solution, and we have successfully explored the connected factory example. And then I have built my own model of a connected factory that incorporates an area of personal interest of mine. And that's the end of today's experiment, and thank you.